Hi, today we are going to discuss about the solution of the free particle Dirac equation. Free particle means our particle is free from all potentials. If a particle is free from all potentials from ordinary quantum mechanics and also from the classes of Klein-Jordan equation, we already know that the solution, the wave function should be in the plane wave form. So we assume the solution of the free particle Dirac equation should be in the plane wave form. Let it be psi of p is equal to e raised to minus I by h cross x mu p mu u of p. We know that this psi of p is a 4 component spinor. So this u of p also be a 4 component spinor. So our target is to find this 4 component spinor u of p. So for finding this u of p, let me substitute this psi of p in the Dirac equation. We know that the Dirac equation as gamma mu dou mu minus m naught, see this m naught is the rest mass, times psi is equal to 0. On substituting this psi here, we get I h cross gamma mu dou mu minus m naught c e to the power minus I over h cross x mu p mu u of p is equal to 0. Only this exponential part have the spatial dependence. So on opening the brackets, this spatial operator only acts on this exponential part. So we can write this expression as minus I by h cross x mu p mu minus m naught c e to the power minus I by h cross x mu p mu u of p is equal to 0. This term is actually I h cross gamma mu. The action of this dou mu on this exponential part pulls out minus I by h cross p mu. So this is minus I by h cross p mu times this exponential minus I by h cross x mu p mu. This I into minus I is 1, this h cross and this h cross cancels. So what we get is gamma mu p mu times this exponential e to the power minus I over h cross x mu p mu. If we take these exponential factors outside this bracket, then we can write this expression as gamma mu p mu minus m naught c u of p equals 0. This is a pure algebraic expression. So we can simply find u of p from this expression, and substituting that u of p in this expression for psi of p will give the free particle solutions for the Dirac equation. So for solving this algebraic expression, first we need to write this expression in matrix form. We can write this gamma mu p mu minus m naught c as gamma 0 p0 minus gamma 1 p1 minus gamma 2 p2 minus gamma 3 p3 minus m naught c. We know that the zeroth component of the time component of the energy momentum 4 vector as E by C. So this is gamma 0 E by C minus gamma 1. Let me replace this P1, P2, P3 with X, Y, Z respectively. So we can write this as Px minus gamma 2 Py minus gamma 3 Pz minus the rest mass m0 times C. We can write this expression as gamma 0 E by C minus gamma times the vector P minus m naught C. Let me write this expression in matrix form. So gamma mu P mu minus m naught C is equal to the gamma 0 matrix is, we know that it is 1 0 0 minus 1 times E by C. In fact, this gamma 0 matrix is a 4 cross 4 matrix. So this 1 and this minus 1 are 2 cross 2 matrices, and the gamma matrix is actually minus sigma. These sigmas are Pauli's spin matrices, and also we know that Pauli's spin matrices are 2 cross 2 matrices. So in fact this is a 4 cross 4 matrices times dot with P minus m naught C. This dot product is actually 0 sigma s minus sigma x 0 px plus 0 sigma y minus sigma y 0 py plus 0 sigma z minus sigma z 0 pz, and also this whole sigma x, sigma y, sigma z are 2 cross 2 matrices. So this, in fact, these matrices are 4 cross 4 matrices. In fact, there is an identity matrix with this m naught C, that is 1 0 0 1, and this identity matrix is a 4 cross 4 matrix. I can write this expression as E by C minus that m naught C, and the second element is, here it is 0, here it is sigma dot P, and that is there 0 minus sigma dot P, and here it is 0, it is minus plus, so it is sigma dot P, and that is 0, and this here it is minus E over C, it is 0, and there it is minus m naught C. So I can take this minus common, right, this. On substituting this value of gamma mu P mu minus m naught C in this equation, we will get E by C minus m naught C minus sigma dot P minus E by C plus m naught C times the u of P, that is, here it is UA and UB, which is equal to 0. In fact, this UA and this UB are 2 cross 1 spinors. So in total this as a wall is 4 cross 1 spinor. On evaluating this expression we get E by C minus M naught C times U A minus sigma dot P times UB. And the second element is sigma dot P times UA minus E by C plus M naught C times UB is equal to 0, 0. From this equation we can write two coupled simultaneous equations. One is E by C minus M naught C times UA equals sigma dot P UP, and the other one is E by C plus M naught C times UB equals sigma dot P U sub A. Now we are going to find this sigma dot P. We know that the Polish spin matrices are this is sigma x times px plus the sigma y matrix. We know that it is a 0 minus I 0 and times py plus the sigma SL matrix. We know that the sigma SL matrix is 1 0 0 minus 1, this times pz. So this as a word gives 0 0. So first element is pz and the second element is px minus ipy, and here it is px plus ipy, and here it is minus pz is equal to sigma dot P. From this equation you can simply see that this sigma dot P is a 2 cross 2 matrix, and also from this equation also you can see that this sigma dot P is a 2 cross 2 matrix because this UB, this UA, this UA, this UB are 2 cross 1 matrices. From these two equations I can write another two equations in which this sigma dot P comes in the numerators. So we can write UA is equal to sigma dot P UB divided by E by C minus m naught C. And the other equation is from this equation is UB is equal to this sigma dot P divided by this E by C plus m naught C. M naught C times this UA. Why we keep this sigma dot P in the numerators? Because sigma dot P is a 2 cross 2 matrix and we don't know to divide something with a matrix. That's why we keep this sigma dot P in the numerators. We already evaluated this sigma dot P here. So let me substitute this value of sigma dot P here gives UB is equal to 1 by E by C plus m naught C times sigma dot P. We know that sigma dot P is Pz Px minus Ipy Px plus Ipy minus Pz times UA. In fact, this equation is a connection between two 2 cross 1 matrices. Let me ask you, what is the number of independent 2 cross 1 matrices that we can take? It is actually 2 because let us imagine this is a 2-dimensional plane. We all know that the independent vectors that we can draw in this plane is actually 2. These are 2 independent vectors and also these are 2 independent vectors. So if we take this as a reference frame and draw 2 vectors like this, we can represent these vectors by column vectors. This is 1, 1, this is x is minus 1, y is 1. So this is minus 1, this is 1. So in a similar way, we can also take 2 independent UAs. So let me ask you, what is the most simple combination of UA that are independent? So the independent combination of UA are UA is equal to 1, 0 and UA is equal to 0, 1. If we substitute these UAs here, we get corresponding UBs here. So let me do that. Plus m naught C times Pz Px minus Ipy Px plus Ipy minus Pz. The first combination is 1, 0. So that gives Pz by E upon C plus m naught C. The second element is Px plus Ipy over E by C plus m naught C. And this is actually, we can take this C to the numerator, that gives Cpz divided by E plus m naught c square, and here C px plus Ipy over E plus m naught c square. As next, let me put the next linear combination of UA here. That gives UB is equal to 1 by E upon C plus m naught c times Pz Px minus Ipy Px plus Ipy minus Pz times 0 1. That gives Px minus Ipy over E by C plus m naught c and minus Pz upon E by C plus m naught c. On pushing this c to the numerator gives m naught c square times Pzc. Here it is c times m naught c square. We know that the 4 cross 1 spinor u of p is actually the combination of 2 cross 1 spinor ua and the 2 cross 1 spinor ub. And this u of b times the exponential part gives the solution of the Dirac equation that we have already seen it. So let me substitute the values of ua's and ub's here, and let me call the first solution be u1. So the ua is 1 0 and the ub corresponding to this 1 0 is c pz divided by E plus m naught c square. And the next element is c px plus Ipy over E plus m naught c square. And this u1 times the exponential part gives the first solution for the Dirac equation. From this combination of ua and ub, we can write the second solution. Let me call the second solution be u2. And this u2 is 0 1 c px minus Ipy over E plus m naught c square minus Pz c over E plus m naught c square. We already talked that keeping sigma dot p in the numerator, we can write ua is equal to sigma dot p over E by c minus m naught c times ub from this equation. On substituting the value of sigma dot p gives ua is equal to 1 over E upon c minus m naught c times the matrix sigma dot p. Sigma dot p is pz px minus ipy px plus ipy minus pz times ub. Ub is let me first do it as simply ub. Like our previous case, the most simple linearly independent combination for ub is 1 0 and 0 1. Let me first give ub as 1 0. This simply gives let me call that solution be u3 as cpz by e minus m naught c square c px plus ipy by e minus m naught c square one 0. And if we give the value of ub as 0 1, let me call the corresponding spinner u4. u4 we will get u4 as c px minus I py over e minus m naught c square minus c p z over e minus m naught c square. Then the value of ub is, this is the value corresponding to ua, and then the value of ub as 0 1. And this u3 and u4 times the exponential part gives the solution of the Dirac equation. So to analyze the properties of these four solutions of Dirac equation, we need to first write the Dirac equation in rest frame. We know that the Dirac equation is, if you just skip the video backward, you can see that the Dirac equation is gamma mu p mu minus, if I write Dirac equation as m naught c times u of p is equal to 0. And also you can see that if you skip the video backward, you can see that if you write this thing as in matrix form, like e by c minus m naught c minus sigma dot p plus sigma dot p and minus e over c plus m naught c times ua up is equal to 0. And these two equations are equivalent. In rest frame, we can write this equation as, in rest frame, we know that the momentum is 0 because we are traveling with the particle, we are traveling with the free particle, so the moment of the free particle is 0 in the rest frame. So we can write E over C minus m naught C. The momentum P is actually 0, and here also 0, 0, 0 minus E over C plus m naught C times this UA in the rest frame, UB in the rest frame is equal to 0. We can split these matrices like 0 minus E over C minus m naught C, 0, 0 m naught C a big bracket times UA UB is equal to 0. So if you sum these together, you will get E by C minus m naught C, and this minus comes in common, and that will give minus E by C plus m naught C. And in this equation you can take this m naught C outward. I mean, we can write this as 1 0 0 1 m naught C. And if you open this big bracket by taking this UA UB inside, you can simply write this equation as E over C 0 0 minus E over C you just take the UA UB inside is equal to m naught C times you just take the UUB inside and take the one part to the RHS. That will give this E by C 0 0 minus E by C UAUB, which is equal to m naught C identity matrix times UAUB. And this identity matrix times UAUB is actually simply UAUB. So you can write this as UA UB. Let us substitute the U1 spinor here. And you know that the U1 spinor is actually U1 is equal to C 1 0 C PZ over E plus m naught C square and C Px plus IPy over E plus m naught C square. And this is actually the Dirac equation in rest frame. So we need the U1 spinor also in the rest frame. So in rest frame, this Pz and this Px Py all are 0. So we can write the U1 spinor in the rest frame as this Pz is 0 and Px Py all are 0. So the U1 spinor in the rest frame as once we get 1 0 0 0. This is the U1 spinor in the rest frame. So if we substitute this U1 spinor here, you will get the energy associated with the U1 spinor. So let me do that. In fact, this matrix is a 4 cross 4 matrix, and also this is a 4 cross 1 spinor, and also this is also a 4 cross 1 spinor. So if we substitute this spinor there, you can see that it is E over C 0 0 0 0 E over C 0 0